All right, properties of logarithms. Sorry, I just want to see what letter they use real quick here. Do they use U and V or U, M and N? Okay. Different books use different letters. All right, let's go through the properties real quick, but these work the same way as exponents. When I have exponents and I have like x squared times x to the fifth, what do I do to the exponents? You add them, right? Okay. Same thing with logs. If I have log of something plus, I guess it'd be times if we do the same order. Log of m times n, I can actually separate those out and make it log of m plus log of n. Okay, so we actually work on, they call expanding it, where you take one log and turn it into two different logs, or contracting it. What do they say there? They don't have a number or word right there for it, but condensing it, where you have two logs and you combine them as one. So multiplication and addition go together. If I have an exponent and I have divide them, what do I do to their exponents? Subtract them. So I am going to do the same thing with logs. So if you ever forget what to do with logs because they are new, just think back to exponents. It's all the same way. So if I have a log of something divided by something, I can separate it out and subtract them. Okay. The other one that's a little bit different is if I have log, sorry, I'm trying to use the same letters as Alex. They use P. If I have m to the p, if I have an exponent of this one, by the way, I'll say that in just a second. If I have an exponent of something, what I will do is say that this drops down out in front. So I can actually write this as p times log of m. And then my caveat here is they have to have the same bases. Which I don't think Alex will ever give you one with different ones. But that's kind of the key thing there, is that when you multiply, you add. When you divide, you subtract. Same thing as exponent. And then if you have something to the power, you can drop it down and multiply it. That comes in super handy when we get to solving equations. We will use that a ton. But they do have to have the same bases every time you do this. So, basic properties of logarithms. I believe that is all this section is about. I think instead of writing all that out, I'll just write it on here. Because this section should be super easy. It's just breaking them down. So on the first one, you see subtraction. This is just learning the properties. You see subtraction, so they all have the same base. So that means I can combine them as one. So this is going to be a subtraction, so you think divide. So my answer is 9/2. I can combine them as one as a division problem. If I get real fancy here real quick. If I can do that, that'll make it look better. Oh no, it doesn't send it to the back. Well, let's try this one more time. Haha. Okay. So 9/2. On this one, it says, okay, you got an addition or addition has to do with multiplication. So we're kind of figure out this number right here. So 5 times what gives me 35? This would be 7. Okay. So you can do 7 times 5 would be 35. Okay. So you can take two logs that are being added and just multiply those together and get your answer. On this one right here, this is doing the property. So you have this number being multiplied out in front. So I can actually move it to an exponent. This would be 2 to the third power. That's the weirdest one. But if you're ever multiplying a number that are in front of the log, you can actually just move it into an exponent, or you can drop it down and go backwards. So all of these are reversible. You can do from division and separate them out to subtraction. That's probably the one thing, but we'll do a bunch of that here in just... What is that topic? Okay. So why is this useful? Sorry, I was trying to see if they'd always give us a nice number here. They will. Okay. Why is this useful? So on these right here, maybe we can use the properties to figure out what this is. So I don't know what this is. Like, I don't know what this is individually, and I don't know what this is individually. But maybe if we use our properties, it will help us figure these out. So for A right here, I can take this 2 and I can move it up here. So I can say log base 2 of 3 squared. Well, that's the same thing as, I'm just kind of working this side real quick. Log base 2 of 9, right? 3 squared is 9. All right, well, I don't know. This is saying, remember what a log is. Log is saying 2 to what power is 9. Well, I don't know what that is, so let's go ahead and look at the second part. And this is saying 2 to what power is 36. So I can't solve either of these right now. But the subtraction right there means that I can rewrite it as a division problem and do 9 over 36. And then I have log base 2 of 1/4. Ooh, can I do this now that I've simplified it? So 2 to what power is 1/4? Any guesses? It would be -2. So this answer right here would be -2. Because 2 to the -2, you got to put it underneath. So 1 over 2 squared. 1 over 2 squared is 1 over 4. All right, now part B, kind of going to go opposite here. The exponent is going to drop down. Exponent's going to drop down, so I have 8 times the ln of e plus 4 times the ln of e. We need to talk about this. This is something you're going to run into a lot. I can't exit out of this, man. Okay, the ln of e. Let's work out the ln of e real quick. Ln of e, we'll put equals x. This is base e, right? So this is saying e to what power is e? Well, what exponent do I use if you get the same thing? 1. Okay, so the ln of e, this is a big thing. The ln of e always equals 1. Like, we will run into that a lot. So it makes it go away nice and neat. So the ln of e equals 1. So this really becomes 8 times 1 plus 4 times 1. So 8 plus 4 is 12. Okay. So again, I don't know what e to the 8th is, but if I can get rid of that 8 by dropping it down out in front, it makes it go away. That was, we jumped ahead a little bit. I feel like it wouldn't hurt to do one more of those real quick. I think the e's are all going to kind of work the same way. But all right, so for part A, I'm going to take this 3 and move it up there. So I have log base 3 of 72 minus log base 3 of 2 to the 3rd power. 3 to the 2 cubed would be 8, right? Well, minus, I could rewrite this as log base 3 of 72 over 8, which is log base 3 of 72 divided by 8 would be log base 3 to the 9th. 3 to what power is 9? 2. 3 squared is 9. So you just got to start using those properties and moving them. Here you combine them, and you will be able to figure out an answer. And again, the reason we do this is because I don't know what log base 3 to 72 is, and I don't know what log base 3 of 8 is. But if I combine those using the minus and making it division, then I can actually work it out. For part B, same thing as we did last time. You drop the 6 down, drop the negative 12 down, so it becomes 6 ln of e minus 12 ln of e. So it'd be 6 times 1 minus 12 times 1, which would be 6 minus 12. The answer would be negative 6. All right. So on those ones, y9z. On those ones, we kind of condensed them. We brought them together as one. On these ones right here, the next two topics, we are going to work on expanding them. Okay. So I have one log, and I want to separate it out to multiple logs. So this one is being multiplied, so I want to change it to addition. So it'd be log base 1 of y, log y to the 9th plus log z. And you'll get to a point where you can kind of do this in one step. But just to show you right here, so you're separating it out as multiplication. So we change it to make it 2 logs and make it addition. And then the last step here is we can take this 9 and drop it down out in front. So 9 log y plus log z. ZX5. Okay. For the next one, it is division, so we're going to separate it out to subtraction, log base z minus log x to the 5th. So you always do the numerator first, minus the denominator. So we're separating it out into two different ones. And then we take this exponent, and we drop it down out in front, so it'd be log base z minus 5 log x. Feel like we did an addition one and a subtraction one, so I don't think they're going to change very much, but I was just checking. Let's go to the next topic. If it gets super hard, I'll come back into that one and do a couple more. Yeah, let's move to the super hard ones.
I'm not sure how to help with that.
Is that Siri? I don't know. Okay, they're all super hard. All right, I'm going to go back to the other one, just show you one little shortcut that I would use. ZX7. Just to help on the before we get to the long one. Okay, I'm going to do this in one step because it's pretty easy to do in one step. I mean, if we need to do it more, just let me know. But so this is multiplication, so I'm going to change them, switch it to addition. So I do log of z plus log of x to the 7th. Instead of writing x to the 7th, I know that 7 is going to come down and drop out in front. That's all I'm doing is skipping a step right there. But anytime you have an exponent, you know it's going to go out in front, right? Like that's the rule. So it's not that much different than what we were just doing. I just did that problem in one step because it does make life a lot easier. So just wanted to show you that before we do go to one of these hard ones, because there isn't really a medium one. It went straight from easy to hard. Let's do this one first. X5Z32. X5Z32. I guess there wasn't. That was probably a Y. Close enough. All right. So we've got a bunch of different things, but you're just going to take this piece by piece and do it. So we're going to separate it out. So we're going to do, there's a division, right? So we're going to do X5. So instead of writing the 5, I'm going to write 5 in front. Everybody okay with that? Like instead of writing x to the 5th, I do 5 times log x. Minus, now this is where you got to be careful. I'm going to put a bracket right here because I have several things on the denominator. So I do a bracket, a log base z, but then it's times this cube root of y squared. So I'm going to do plus, how could I rewrite how could I rewrite this to be just an exponent?
1/3.
You said 1/3, right? But there's a 2 underneath there too, right? So it'd be 2/3, right? Okay. So y, yes, that would the cube root is 1/3, but since I have y squared underneath, it'd be y 2/3. Okay. So now I do plus log y to the 2/3. Well, instead of writing 2/3 here, I'm going to write it here. Okay. So now the reason, so this looks right? This looks good because I have, let's see, I got my numerator, log x to the 5th, or 5 times log x. On the bottom, I have log z times 2/3 log y, which is y to the 2/3. So that looks good. Now, what you have to do here is you have to make sure that you put the parentheses or the bracket or whatever around those two, because this is my numerator, and then you subtract and get your denominator. Okay? If you were working this out further, you would actually like distribute a -1 through here, and this sign would change to a minus. You can think about it that way. Like, that does work in your head if this makes sense, but you could do I divided by log z, and I divided by 2/3 log y. Like, if that makes sense in your head to do it that way, you can. Alex should accept either answer. Okay. But B, you got to be careful with your signs. I always like to just do the parentheses because then you can clearly see what's the numerator and what's the denominator. Let's do one more of those. I think we're about done though. There's 2 topics left, but we already did one of them. Oh, I need to do the one with that one. Y z3x5. I don't know. Close enough. Oh, it's y on top. I was way off. We'll do what they said, because we didn't have 2 on top last time. Y z3x5. Okay, so the first thing, how can I rewrite this to get rid of that square root? This would be to the 1/2, right? I can do this whole thing to the 1/2. All right, so I'm going to get that 1/2 way out in front of everything. So on the top, I have log y plus log of z to the 3rd power. So I'm going to write the 3 in front. That's kind of the step that I skip, but it's so easy to skip because instead of writing z cubed, I'm going to move that 3 out in front. And then I'm going to subtract. I only have one thing in the denominator, so I don't really need another bracket here. I'm going to subtract log of x to the 5th power. Instead of writing it here, I'm going to write it in front. And I have my answer here. Now, the hard thing about this is you have that 1/2 out in front. The whole thing is to the 1/2 power. I'm doing the square root of the whole thing, so everything is going to be multiplied by 1/2. So you could change your answer. I think Alex will accept the blue one. You could change your answer to... Oh, wait. We got to multiply by 1/2, don't we? Multiply everything by 1/2. So it just puts a 2 underneath everything. So if you could go ahead and multiply and distribute that 1/2 through, but I believe Alex will take the blue one as the answer. Y'all can tell me if I'm wrong. All right, there's 2 topics left, but one of them is that change of base formula, which we already did. Go away. One of them is that change of base formula that we already did. So let's do this. Writing an expression as a single logarithm is our last topic here. 1/4 z plus 7 minus x. Okay, most of the time when I do examples, I don't do anything with the bases here. This one does have log base a. to do these properties, all the bases have to be the same. You don't really do anything with it. You're just going to have to write that into your final answer. But we are going to try to combine this to 1. So the first thing I want to do is get these exponents up here. Get the numbers out in front to be exponents. So I would do, we can kind of do this all as one step. I think these are easy to do as one step. So you have a subtraction, so you know there's going to be a division, right? On the top, I have z to the 1/4 and then y to the 7th because those are both being added. And then when I do the subtraction, I put my division bar and I have an x on the bottom. Technically, you could probably change z to the 1/4 to the 4th root of z, but I don't think you have to. I would just leave that as my answer. So on these, I hate to say it, but I feel like these are very easy just to do in one step like that. That's the way that I would do it, and I know any chance y'all get to do something in one step, you're going to do it. I hope it's not skipping too much for you. So like if I was doing this problem right here, I do log base b. I do see a minus sign, so I'm going to make it a division. And then I have x to the 1/3. So I move that 1/3 to the exponent. And then I have w to the 5th. That's being added, so it's going to stay in the numerator. And then I have a y in the bottom because that's after the subtraction. Okay. Oh, here's a little bit of a harder one. But still, I feel like these are very easy to do. So this one is addition. So I don't need a division bar. I'm going to have, I don't think you have to work these out. 5z plus 1. Oh, man, I put a parentheses right there. I didn't mean to. I better put a parentheses. 5z plus 1 to the 6th power because it's being multiplied by 6. And then it's plus, so I'm going to multiply again, z plus 2 to the 1/4. So, like these, I don't want to like skip ahead because I know I'm teaching you how to do it and I know how to do it. But like, I think it's very easy just to kind of write these in here and do this, and you just go step by step. There is no division on this one, so I don't use a fraction bar. And then I just do 5z plus 1 to the 6th power, and then z plus 2 to the 1/4 power. It's just a plus of being multiplied. Does that kind of make sense? Have y'all seen this before? Do y'all do this stuff? No? Okay.